Hey guys, welcome to question MM217 of the Maths Methods Fortify study guide. Now we've got this graph y equals negative root x, and we've got a normal to this graph, which is given by y equals 6x plus c. We need to find the value of c. So firstly guys, probably the easiest thing to do here, or to recognize what to do, is to draw this diagram. Alright, so recognizing what y equals negative root x looks like, and what that normal actually means. So guys, keeping in mind that a normal is a line that's perpendicular to the graph at a certain point, okay? So it's perpendicular to the tangent at that point, all right? So our first step is to figure out the gradient of the tangent of this graph, right? Because we're gonna need to work out our x values, okay? So we need to work out this point so that we can work out c, all right? So if we have this point here, we're going to be able to sub in x and y for x and y, and then find c based on that. Really sorry about the noise in the background, guys, if you can hear that. There's construction going on at the moment. So in order to find this point, we're going to need to find the point that the tangent touches at this point. So we know that the gradient of our normal is equal to 6, because that's our number out the side of the front of the x. And because this is perpendicular to the tangent, it means that our tangent gradient is going to be -1 over the gradient of the normal, all right? Which means that we have -1 over 6. Okay, so the gradient of our tangent is -1 on 6. This is our first mark, actually, guys. So this is a really good spot to get to. Now, we want to find this point, like I mentioned, all right? So the way that we do that is we know that the gradient of this graph is going to be -1 on 6 at this point, which means that we can find our gradient function and then sub in our gradient -1 on 6 to find our x value, okay? So we know that y is equal to negative root x. If you didn't understand what I just said, you'll understand as we go along. We know that y is equal to negative root x, which is the same as negative x to the power of 1/2. Now, the derivative of this, because keep in mind guys, we don't have our calculator here either. This is also a 3-mark question. I didn't mention at the start, but I'm sure you've already figured that out. The derivative of y equals negative x to the power of 1/2 is -1 over 2 root x. If you're not sure how that works, just play around with this power and you'll figure it out. Now we know that the derivative or the gradient of the original function is -1 on 6 at the point that we're looking for. So we can sub that in for dy dx and say that -1 on 6 is equal to 1 on 2 root x. And then from there we can actually just rearrange and find x. So from here we get -6 equals, oh sorry, this is a negative. -6 equals -2 root x. Dividing both sides by -2, we get 3 equals root x. And then we can just square both sides to get 3 squared equals x, which means that x is equal to 9. Awesome. This is our second mark. So what we've just found is this point here is x equals 9. So we know that it's 9 something. We don't know what that y value is yet, but we can find that. So the next part is finding our y value. All right, so we know that y is equal to negative root x. We know that x is equal to 9, so we can simply sub in 9 for x, which gives us -3. So this y value here is -3. Now, we know that y equals 6x plus c passes through this point, which means we can just sub these values in for x and y and therefore find c. So I'm just going to rub out this bit here so we can get back on track. So we know that y is equal to 6x plus c. And we also know that it passes through the point 9, -3. So what we then do is just sub in these x and y values. So -3 is equal to 6 times 9 plus c. -3 equals 54 plus c. So therefore c equals -57. That's our final answer and our third mark. So guys, if you have any questions about this, hit me up in the comments below. It is a little weird, but I think the biggest thing is just recognizing that you can use the gradient of the normal to find the point on the original graph. And you'll get better at these over time, especially if you're doing these throughout the whole year. So as I said, let me know if you have any questions, but otherwise thank you for watching and have a great day.